Hey everybody, Trey here. Welcome back to another video. Well, let's talk about what happened on Friday, November 4th. We had an outbreak of severe weather across the ArkLaTex region, including an outbreak of possibly significant tornadoes. We've already seen one rated EF3 and another rated EF2 so far. And there could be more significant tornado ratings on the way, perhaps including this one here. I was able to get pretty close to this one near Emory and Sulphur Springs, Texas. That was a pretty cool sight to see. Unfortunately did some damage, as did many of the other tornadoes that occurred on this day. It was a pretty significant event, pretty high-end parameter space, and there was as you can see here, quite a few tornado reports here mostly within that moderate risk area in the southeast Oklahoma, northeast Texas, southwest Arkansas vicinity, but extending all the way up into northwest Arkansas there. And there were a number of long track supercells as well, some of which produced long track tornadoes. This was the one that I was able to get on, the Emory to Sulphur Springs one. This is the entire rotation track here. You can just see some of these tracks here, very lengthy, and it was one of those days that was able to foster these significantly long track supercells and tornadic supercells at that. Before we get started here, I want to give a shout out to all the Weather Service offices that were involved in this event. NWS Tulsa, Little Rock, Norman, Dallas-Fort Worth, Austin, Shreveport. The warning process went extremely well, I thought, on Friday. There were, as you can see here, lots of different tornado warnings, and everyone did a great job in getting those warnings out in a timely fashion, and no doubt saved some lives. Also want to give a shout out to the Storm Prediction Center. They did an absolutely phenomenal job forecasting this setup. From going back all the way to the day 7 outlook that was outlined for this setup. We don't often see that even in spring, let alone in the fall season. So this event was extremely well forecast. The day 3 enhanced special upgrade leading up to the moderate risk upgrade on Friday morning. This is a map of all the tornado warnings and tornado reports overlaid on top of the SPC outlook contours, and you can see most of those tornado warnings and tornado reports fall within those enhanced and moderate risk areas. So phenomenal job to all the entities involved in this event. No doubt got the information out in a timely manner to definitely save some lives in such a significant event. So on the morning of the 4th, there was a large enhanced risk area from the ArkLaTex vicinity down toward East Texas with an attendant 10-hatched significant tornado area extending basically from southeast Oklahoma down into the eastern portions of Texas, along with a damaging wind and large hail threat. But that was upgraded by the 1630 outlook here to a moderate risk right over the ArkLaTex region, with a bump up in tornado probabilities to a 15% hatched and an added 45 hatched damaging wind contour. So the threat for strong tornadoes and significant damaging winds was increasing throughout the morning, and that is the reason they bumped the probabilities up here. So let's dive into the meteorology behind the event. Let's start at 500 millibars here. And as we pointed out in our forecast discussions, there was a very highly amplified, strong, potent storm system, potent trough, moving in to the southern plains from the western half of the country. Started off as kind of a positively tilted feature here, but with time it kind of took on a more neutrally or negatively tilted orientation here. You can see as it moves into the southern plains, it takes on a more neutral tilt there. Broad area of strong winds rounding the base of that trough, moving into the exit region of that trough. Nice divergence aloft here across the Oklahoma and North Texas region here. Of course, we've talked about this plenty of times before. Divergence aloft is the spreading apart of the winds at the upper levels of the atmosphere, creates that void there, and the atmosphere wants to fill that void by bringing air up from below to fill that void, and that is how you get large-scale rising motion favorable to initiate storms in a severe weather environment. So, very strong trough here. And you can see we have a closed contour here. Some of the models were showing a little bit more of an open wave, a little bit more of an open solution here, but it turns out that this was kind of a closed trough here moving into the southern plains. Now keep in mind here, this is at 4 p.m. Central Daylight Time. Notice that your main band of strong winds aloft is still well back here in northwest Texas into Oklahoma. our target area is over in here. And you can see that the winds aren't quite as strong. So the overall forcing was a little bit more subtle. If we didn't have subtle forcing in the warm sector, which we'll talk about in a second, and our target area was more kind of under the left exit region of this trough, we would have seen a lot more forcing and probably a lot more of a messy, disorganized sort of storm mode. But that was not the case. Forcing was a little bit more subtle farther out to the east, some subtle short waves moving through, and some surface features that we'll talk about here shortly that assisted in providing a more discrete storm mode. Let's look at the surface here. So this is at 13Z, so the morning of the 4th. And so let's see what we have going on here. We've got basically a cold front extending from the Great Lakes region up into Canada, down through the plains. That was sagging slowly southeastward. Had some convection along it during the morning and afternoon hours, but that continued to sag southeastward throughout the day. And we had this kind of broad, sort of strung out surface low here, kind of centered across northwest Texas. And generally, these sort of more strung out, or banana lows, as we kind of colloquially call them in the chasing community, they often are not as favorable for severe weather, rather than a more compact sort of surface low. In a sort of compact surface low scenario, you get a little bit more backed winds out ahead of the surface low, a little bit stronger flow in the low levels as well, and that helps further enhance the wind profile and really pump in that moisture, that warm, moist air from the south or southeast up into the target area. Not usually the case with these banana lows, but what was going to happen throughout the day here is that low is going to kind of consolidate and deepen slightly. You can see here it kind of deepens a little bit, consolidates here just south of the Red River, and we got nice backed flow out ahead of that, especially along the Red River. Down to the south, a little bit more flow that was out of the due south to south-southeast, but still was able to really start pumping that moisture up into the region ahead of the trough's arrival into the area. So let's go to 850 millibars here, look at our low-level jet, and we'll see that we have a nice broad sort of circulation here, broad cyclone here in the low levels over the central plains, with a very broad area of low-level jet here extending from the Great Lakes region all the way down into the southern plains. 40-50 knots of flow here at about a kilometer off the surface was really able to, one, enhance those wind profiles and really pump that moisture in from the Gulf. And we talk about that Gulf moisture here. Let's look at our surface map. We'll go forward in time just a little bit. This is at 13Z here. And you can see already early morning here, we have almost mid-70s dew points here across the Texas Gulf Coast into South Texas. And 70s dew points extending all the way up almost to the Dallas-Fort Worth area, with mid-60s up into southeast Oklahoma. So very significant low-level moisture here for this event. It's been kind of the issue with some of these fall season events so far, is we haven't had enough moisture to work with to get significant severe weather. Not the case for this event, as that reservoir of very juicy air was already set up over Texas into Oklahoma and was only forecast to improve throughout the day. So we go on with time here. Let's go to about 17Z here. So this is about lunchtime when storms kind of started to get going. And so you can see our surface low centered out here across northwest Texas right in here. Our cold front, you can see where the wind shift is here right in this vicinity. It had just gone through the Oklahoma City area. And we also had a dry line out here across west Texas. So you can see dew points out here, Fort Stockton in the 30s here, with 60s dew points out here, San Angelo and Sonora. So our dry line was located somewhere in here. And notice how broad of a warm sector we have. Just a large area of open warm sector that was ready to be acted upon by these features. Now, I want you to look closely here near the Dallas-Fort Worth area. Notice that we have a little bit of convergence going on here at the surface, kind of south-southwesterly winds here just on the west side of Dallas-Fort Worth, which is right in here, and more southerly or south-southeasterly flow here leading up into Dallas-Fort Worth. This was what we call a prefrontal confluence band, and this was setting up just on the west side of the Dallas-Fort Worth metro area. And this confluence band, you might say, well, it's not really very convergent winds there. But if you have one of these in the open warm sector, this is just enough to get storms to fire up in the open warm sector. And by nature, the forcing along these prefrontal confluence bands is a lot less than, say, along a cold front or a dry line. So by nature, you're going to get more discrete storm development along these prefrontal confluence bands because the forcing is so subtle along them. And that was the case here. It was setting up right on the west side of the Dallas-Fort Worth metro area. And this was kind of forecast, and you could clearly pick it out on the surface map. So it was kind of a foreboding situation for the Dallas-Fort Worth metro area. If we take our prefrontal confluence band and we look at our shear vector orientation with respect to the prefrontal confluence band, which would be our initiating boundary of sorts here. We go on with time, we'll go on to about 17Z. So our prefrontal confluence band setting up just right over Dallas-Fort Worth here, something like this. Our shear vectors are definitely enough off of the prefrontal confluence band to have a somewhat more discrete storm mode as well. So the fact that you had more subtle forcing out well ahead of the main trough, whose kind of the main portion of the trough was still well back out in here. The main forcing from that trough was well back here to the west. So you have overall subtle forcing along this prefrontal confluence band, and you have bulk shear vectors that were enough perpendicular to the initiating boundary here, that confluence band, that we were looking at a pretty good chance for discrete storms, which of course enhances the significant severe weather risk rather than a more linearly organized system here. So once I was looking at those surface maps, I'm starting to get a little bit of a pit in my stomach because they were setting up just near some major metropolitan areas there near Dallas-Fort Worth, and given the environment that was in place that we'll talk about in a second, was looking pretty foreboding there throughout the morning hours. So here's our radar image starting at about 10 a.m. Central Daylight Time here. We have a nice swath of just showers here across southern Oklahoma and North Texas, and these were forced by warm air advection, or WAA. And what happens with warm air advection is that flow, that strong flow in the low levels that is pumping that warm moist air into the region. Well, that is sometimes enough to force showers and storms to fire up, and that was the case here with this band of showers and storms here just northwest of the Dallas-Fort Worth metro area there. These were forced by the warm air advection, and with time they became more and more numerous, and then between about 16 and 17Z, so 11 a.m. and 12 p.m., we started to see an increase in the reflectivity with some of these showers, and the lightning output increased as well. And that was our first sign that synoptic scale or large-scale ascent was beginning to encroach into the region. So let's look at some soundings here. And if you recall, in our forecast discussion Friday morning, we looked at the previous evening's soundings because I was recording that a little bit early. This was the 12Z Fort Worth sounding here. And I said, even with the previous evening soundings, that it was about as textbook as it gets for a look on the morning of a severe weather event. This is what we call a loaded gun sounding. You have a deep moist layer here extending up to about 850 millibars beneath a layer of steep lapse rates aloft known as the elevated mixed layer, or EML. The EML is that layer of dry, warm air that emanates at the surface in the desert southwest and gets transported into the region on that kind of westerly flow in the mid-levels, and it sets up over our moist layer at the surface. And when you have that, the EML keeps the warm sector free and clear of convection in the morning. It kind of keeps a lid or cap on the atmosphere and doesn't allow showers and storms to kind of wreck the environment later on. And we had exactly that in place. We had that capping inversion in place here atop a very deep moist layer. Now I want you to notice here, keep an eye on this capping inversion here and what it does between 12Z and the 15Z special sounding here. This is 15Z, this is 12Z. We'll go back and forth here. Keep your eye on that capping inversion. Notice what happens here. By 15Z, it had actually risen in the atmosphere just a little bit. At 12Z, it was somewhere down in here, and 15Z it had risen a little bit in the atmosphere and was starting to erode. Well, what happens when you have synoptic scale lift is that capping inversion will rise in the atmosphere, it will get lifted, and the air will cool, and as a result, the cap will erode. So this was a textbook sign that synoptic scale ascent was impinging into the region. We also had a deepening of the moist layer here. At 12Z, it was only up to about 850 millibars. At 15Z, it was up to about 750 millibars. So we had continued warm, moist advection there, continued moistening of that deep, moist layer beneath that capping inversion. And that is just, absolutely a textbook look. And the cap was eroding nice and slowly as that synoptic scale ascent moved into the region. And by 18Z here, the cap had completely eroded, and we were ready to go with the significant severe weather event. I wouldn't take this too literally. This saturated layer here, Fort Worth may have released the sounding in an area of showers, and that's why it was saturated here in the low levels. But the main message here is that the cap had eroded by 18Z, and in this kind of wind profile, when you have an unstable, uncapped air mass here, you can see mixed layer CAPE here above 1600 joules per kilogram. With this kind of hodograph, a long hodograph favorable for supercells, and a large amount of curvature in the low levels here, a large amount of veering of the winds with height, you have a pretty significant severe weather event on tap for your area. So, interesting progression of the soundings here. We had the cap eroding by just before about 18Z, and you can see here that these showers become more numerous and they start to cluster together and become storms here. And if you were inexperienced with these kind of events, and this is a southeast type event where you have a very deep moist layer near the surface, and very strong forcing aloft from a 500 millibar trough, you might think that, the storm mode has already turned out to be a clustered mode or linear mode. It's already messy. The day's over. And that is not the case here. And I knew that was going to be the case. I was expecting more storms to fire out here down to the south and southeast away from this early convection. But this early convection started to cluster, and sometimes you need that clustering in these high shear events. If you have just a single updraft in a high shear event, it may not have enough to sustain itself on its own. It may need some friends, some other updrafts in close proximity to it, to create kind of one larger sort of complex and morph into one sort of, supercell, one larger supercell. And because it's a larger mass, it's able to withstand the shear a little bit better and fully take advantage of that highly sheared environment. And that's exactly what happened with this early stuff. You can see it moves off toward the northeast, and it takes on a more kind of larger sort of single supercell right in there. This produced a tornado warning as it moved off into Oklahoma near Hugo and Durant. But we had more forming down here on the south side of the Dallas-Fort Worth metro area. And notice that the warm sector is completely uncapped still. We had that capping inversion. I've said, in my sort of southeast storm chasing sort of checklist, you want a high-end parameter space, you want a discrete storm environment, and you want a cap that holds on throughout the morning and does not allow storms to fire in the open warm sector. And that's exactly what we had here. Very stout capping inversion, slowly eroding with time. And that is what happens with most of these kind of southeast type events. Here's, for example, April 27th, 2011. Keep an eye on to the areas south of this MCS here in the open warm sector. Notice how the warm sector is free and clear, and that is because we had a nice capping inversion stick around throughout the morning and early afternoon hours until storms fire here to keep that warm sector clear. That's exactly what we had happening here. So we had storms start to fire, additional storms firing to the south of Dallas here, and with time, they kind of clustered as well. Got some supercell structures out of these as well. This one here started to wrap up on the east side of the Dallas-Fort Worth metro area. But these were the ones I was most concerned about here. Storms firing near the Waco area and moving off toward the northeast. They were much more discrete in nature here. And there's also a little bit of a subtle difference in the environment up in here, in northern portions of the outlook area, versus areas to the south out ahead of these discrete storms. And I'll show you here on the surface map. Let's go back to the surface map here. So we'll go to 17, we'll go to 18Z here. So, of course, we had a broad warm sector. All of it was favorable for severe weather. But notice out here in kind of along the Red River region, out ahead of these initial clustered storms near DFW, Temperatures only in the low 70s with dew points in the mid 60s. But you had winds that were quite a bit backed out here ahead of that surface low in northwest Texas. So you had very backed winds enhancing the low-level shear, but the thermodynamics were not quite as favorable as areas farther to the south. And you can see down here to the south, ahead of those discrete storms forming near Waco, temperatures in the upper 70s to low 80s down here with dew points in the upper 60s to low 70s. But your low-level winds were not quite as backed as they were in areas farther north. So farther north, you had a little bit more wind shear, a little bit more low-level shear to work with, but the thermodynamics were not quite as favorable for significant severe weather. Still adequate, but not quite as favorable. Whereas farther south, your air mass was a little bit juicier, but your winds were not quite as backed as they were in areas farther to the north. Again, both of these areas were favorable for severe weather, but I had a concern about those southernmost storms because the air was just a little bit juicier, and the low-level shear and the wind shear profile in general was very favorable for severe weather there. So I was watching those closely. Again, the Dallas storms here took on a little bit of some supercellular structure here. This one here started to wrap up a little bit as it moved off toward the northeast. That produced a tornado warning as it moved off toward the north and east. But these storms quickly formed down here, and you can see the very discrete nature of these storms given that subtle forcing along the confluence band there. And they started to take on low-level mesocyclones. The lightning production ramped up pretty quickly, and they took on a supercell shape. You can see this southernmost one started to take off quite a bit. We'll go down here to our radar imagery. So keep an eye on this southernmost one right in here as it moves off toward the northeast. We go on through time. It takes on that classic supercell shape. Nice hook echo there, and a low-level mesocyclone starts to form. Now this storm went through several cycles here. Watch the velocity imagery on the right here. You'll notice that the couplet, or the tornado vortex signature, ramps up, then broadens out and dies, then ramps up, and kind of broadens out and dies as well. And so it was struggling to really kind of root itself and take advantage of the environment. And I was starting to wonder why that was the case. And it perhaps could have been due to that clustering issue that we talked about earlier, needed more storms to fire. But notice these showers down here toward the south of this storm. This one right here was flowing up right into the forward flank of the storm. And we've talked about storm mergers before. One of two things can happen. You can have either constructive interference, where the shower will merge with the supercell, and it will increase tornado production. Or you can have destructive interference, which means that the shower will merge with the storm, and it will kill the storm altogether. So we were kind of waiting to see what would happen here. You can see that the shower moves into the forward flank region, and this one to the south takes on its own sort of supercell shape, trying to become dominant. And so we were waiting to see that storm merger happen. And also here, the environment may not have been completely primed yet for tornadoes. We have sometimes in these kind of southeast type events where the storms will fire before the shear really gets optimal. And you can see here on the morning sounding here, these photographs. Notice this kink right here, this very significant backing in the mid-levels of the atmosphere. And there's been lots of debate on, how does this veer back signature affect the storm mode and overall storm longevity and intensity. And generally, the lower this kink is in the atmosphere, the more of an issue it has, more of an impact it has on storm mode and longevity and intensity. So this may have been still in place here. You can see by 15Z, very pronounced kink there, some backing of the flow in the mid-levels there. And that's because we hadn't quite had the 700 millibar flow yet come in to the region here. Let's look at our mesoanalysis again. We'll go to 700 millibars. And you'll notice here that the main trough at 700 millibars is still well out to the west here. Here's our target area. Here is the main trough here. Winds had yet to really increase in this region until mid-afternoon here. So these storms were firing 16, 17, 18Z, and we started to see an increase in those winds aloft by about 21Z or so, and that's when shear became really, really favorable. Once that mid-level backing sort of worked itself out and the winds sort of started to strengthen there. You can see on the 18Z Fort Worth sounding, we started to get some stronger winds here in the mid-levels and started to negate that sort of the kink in the hodograph. So I think storms fired a little bit too a little bit before shear became optimal. You also had the clustering issue. These were very discrete supercells, and we needed to wait and see what the merger, would do to the storms. So again, this was our target storm here, and this supercell to the south started to take shape and started to compete with it for the ingredients here. It started to become outflow dominant. We were here near Kaufman watching the storm come at us, and it started to kind of gust out, become outflow dominant. You could see a big shelf cloud with it, but the lightning production was ramping up pretty rapidly. So we thought that this storm was just getting going, and it just kind of needed to ingest that storm to the south to really sort of improve its structure and characteristics. So here's our storm to the southwest, bottom left of the screen. You can see it kind of has those two discrete cells kind of exist for a while, and then finally they undergo the merger here just north of I-20 there. You have now one lone supercell here, and you can see rotation starting to ramp up there northwest of Wills Point. Continue on here. Reflectivity ramps up in the core. The couplet continues to increase, and then by the time it neared Emory, you had tornado genesis there, and now one larger lone supercell able to fully take advantage of that improving shear. And that's when it was tornado time with this storm. This was the storm that moved on through near Sulphur Springs and eventually on toward Clarksville, and then eventually Idabel, which took a direct hit from this tornado. There was a tornado emergency issued for Idabel, and we're still rating this tornado, but it looks to be pretty significant based on some of the damage I've seen. This was also the storm that was one of the longest tracked of the event. This was the rotation track based on radar here of this storm. You can see it started all the way down here by Waco as just a little shower, and given the environment, pretty perfect environment, which we'll talk about here in a second, allowed for these supercells to become long track and produce long track tornadoes. Produced tornadoes here all the way from northeast Texas into southeast Oklahoma, even into Arkansas. It went for over 300 miles and ended up as a tornadic mesovortex up here as it merged with the line up here in western Arkansas. So this was an environment that was favorable for very long track supercells here. Let's go down to some RAP proximity soundings here. We'll go here toward Paris, Texas. There was a significant tornado there from the early clustered stuff near Dallas as it moved off toward the northeast there. Produced a tornado that has been rated EF3 near Powderly, Texas, which is just north of Paris along the Red River. You can see here that the environment here, the thermodynamics, not quite as favorable for severe weather, but still adequate. It's still an uncapped, moderately unstable environment here. And this photograph, very strong veering of the winds in the low levels. You can see that the winds here are a little bit more backed. That's why we had quite a bit of storm relative helicity up here, despite the slightly more unfavorable thermodynamics. Over 550 meters squared per second squared of SRH here. So this was an environment that was going to produce long track supercells and perhaps long track tornadoes. This is near Tyler, Texas at 22Z, so as close as I can get here to this Emory Sulphur Springs supercell, and much of the same. A little bit juicier air here, 79 over 71 here at the surface, completely uncapped, moderately unstable, about 1,700 joules per kilogram of mixed layer CAPE. And look at this photograph here, just a pretty textbook photograph, long photograph, strong deep layer shear force supercells that we're going to take advantage of this very strong low-level shear here. You can see the winds are not quite as backed here in the low levels, but we had significant backing and significant streamwise vorticity here in the low levels. We've talked about streamwise vorticity before. When you draw your storm relative wind vector here. Actually, the Texarkana sounding here is going to be a little bit better. This was near the New Boston long track tornadic supercell that we'll talk about in a second. But streamwise vorticity is the sort of, you imagine a football, you throw a football, and you get that perfect spiral. Well, that is the air, these convective rolls near the surface. If that air is spinning and is able to be ingested into by the storm as it tilts into the vertical, and the vorticity is streamwise, it's that perfect spiral, then it's going to be more favorable for tornado production. And here you draw your storm relative wind vector out from the storm motion, the bunker's right storm motion, to your hodograph. Then you draw your horizontal vorticity vector perpendicular to the hodograph. And when these two vectors are parallel, that is when you have streamwise vorticity. And you can see here, all throughout the low levels here, just an absolutely crazy amount of streamwise vorticity here in this environment. So these storms were ingesting this vorticity, and that's why tornado production was so efficient in these storms. Also because you had low-level instability. Low-level CAPE here, about 79, so about 100 joules per kilogram of low-level instability, 3 CAPE, adequate for really starting to stretch this streamwise vorticity and spin into the vertical and making tornado production pretty efficient in these storms. So all in all, this is a pretty textbook environment. This is what Cameron Nixon, the expert on hodographs, calls the forever meso. Very strong low-level shear beneath kind of weaker mid-level shear here. And this might be a little bit better visualized here on some of the VWPs, the vertical wind profiles here. This was the Shreveport vertical wind profile just before 7 p.m. Central Daylight Time here. And you can see much of the same here. Strong low-level shear in the lowest kilometer or two. Beneath weaker mid-level shear, you can see the 2, 3, 4, 5 labels here right on top of each other. So we had fairly weak mid-level shear. And what happens in these environments is you get very compact supercells. If we look at the radar here for the New Boston storm, notice how the storm here, this is our New Boston storm, very compact, very small supercell, consisting mostly of just the tornado cyclone. And that's what happens in these environments. It'll be a compact supercell consisting usually just of the tornado cyclone. But because the low-level shear is so strong, these can produce a long-track cyclic tornadic activity. And that was exactly the case here with this kind of setup. So this was a setup that became more and more favorable with time for cyclic tornadic supercells, and that was the case here. We'll go back here to our New Boston storm. This was the storm that fired up here near Tyler, Texas. Here is our shower here as it first fired up here to the southwest of Tyler, moved off toward the northeast with time, quickly took on that sort of bean shape here. Classic sort of mini supercell shape there. And it quickly developed a low-level mesocyclone moving off toward the northeast in that environment. And it became pretty apparent this was going to be a long-track supercell. The rest of these storms were fairly discrete as well. But notice this one was all by itself, out ahead of even the band of semi-discrete storms out here along the convergence band. So this one, it was getting to be pretty evident that this was going to be a long-track tornadic supercell given the environment and how alone it was. And that was the case as it neared Pittsburgh. It started to produce tornadoes here, moving off toward Dangerfield, and eventually near the I-30 corridor near New Boston. We will move on here. So you can see it moves off toward the northeast here and continues to produce tornadoes even into Arkansas here. It merges with the line. You can see here it's kind of a tornadic mesovortex right in here. So this was a storm that lasted quite a while here, and given the environment, not surprising at all. Take a look at the correlation coefficient here, and this was pretty shocking to see. So you can keep an eye on that correlation coefficient, starting to see a debris signature there, coincident with that strong velocity couplet. Move off toward the northeast, and look how large this debris ball is. This debris signature is just an absolutely massive debris signature there. So no doubt this was a very strong tornado, lofting debris pretty high into the atmosphere. That's what we saw most of the day as well. Some of these tornadoes lofting debris, 30,000 feet in the atmosphere. This was the Ida Bell tornado. This was actually the New Boston tornado that we were talking about here, lofting debris up to almost 30,000 feet. This is correlation coefficient. And lofting debris up to almost 30,000 feet here. That is just incredible. Shows that this was potentially a violent tornado, EF4 plus tornado. We're still waiting for the surveys to be finished, but the ability for these tornadoes to loft debris shows that they were very, very strong tornadoes. One last thing I want to cover here is the overall visibility of these tornadoes. These were very, very visible tornadoes here. This was the Sulphur Springs tornado here. You can see how visible it is. Not wrapped in rain, as is the case in most of these kind of southeast type setups here. This was the New Boston tornado as it neared the town You can see very, very visible here, not wrapped in rain at all. And that is because we had pretty solid venting here with these storms. Oftentimes in these sort of southeast type setups, you'll get these large low-level shear cases, and the hodograph will kind of fold back into itself in the kind of mid and upper levels. And that's when you have sort of rain that starts to wrap around and obscure the mesocyclone from view. And that wasn't the case here with this setup. Notice the storm motion is here, and we had our sort of mid and upper level flow, kind of sort of tail off this way toward the north, keeping the precipitation away from the mesocyclone. We've done this exercise before where we kind of use a hodograph as a proxy for the supercell kind of structure on radar. And notice that in a case where you have the low-level shear and the upper-level shear that kind of wraps around on the hodograph, the supercell, the precipitation will be vented off well ahead of the mesocyclone, and thus making it very difficult to view the tornadoes. Not the case with this setup. You can see here that the precipitation was vented off away from the mesocyclone, and that's how these tornadoes were able to be so visible here. So interesting setup here, a very unique setup. Oftentimes in these sort of highly sheared setups, these southeast type setups, you'll get rain-wrapped tornadoes, but that was not the case with most of these tornadoes, at least these significant ones here in this event. So that'll wrap things up here. Hopefully we went over some things that helped you see how significant of an event this was. You need three things for a southeast environment to produce significant tornadoes, and this is kind of my southeast setup checklist. You need a high-end environment, which we had in spades here, very strong low-level shear amid an uncapped, unstable environment. You need that capping inversion to hold storms off in the open warm sector and to allow the afternoon activity to take full advantage of the environment. And you need a discrete storm mode, which we had, a very discrete storm mode. If we go back here to our zoomed out radar, you'll see here as we go on through the event, just an absolutely kind of a scary situation. Actually, you can see here's our main line of storms along the front / dry line, and just numerous discrete storms down here in the open warm sector, well ahead of the main band, with all of this real estate of a pretty untapped powder keg of an environment to take advantage of. It was overall a pretty kind of the worst case scenario for this event, for these areas, and we had that discrete mode stay discrete until the front finally caught up with it, and it became a more linear organization of the storm. So all these three ingredients were checked in spades, and that's why we had such a significant event. Once again, this shout out to the Weather Service agencies and the Storm Prediction Center, who did an absolutely phenomenal job forecasting and warning for this event. No doubt saved some lives, and we'll see what happens with the damage surveys to see how many significant tornadoes we saw out of this event. So with that, thanks for watching, and we will see you in the next video.